Hi, everybody. I think we're going to get started because, as you know, we've been squeezed from time on every panel. Our first speaker today is Stephen Feiner, and he's going to talk on making AR real. He's professor of communication science at Columbia University, but computer science, sorry. But I mean, I don't like to, put labels on people, but Professor Feiner really is one of the fathers of AR. And I mean, I think without his work over the years and his, sustained interest and putting, getting GPS to work on top of the Columbia University when none of us had even thought of what we could do with GPS signals, it just goes back. And I mean, I can't say how grateful I personally am for all the work he's done, and look forward to his talk today. Now, would you like to come to the stage?
Thank you, Tish. So, in preparing for today's talk, I figured I'd talk about what it's going to take to actually make AR be real. So I think back to 12 years ago when I wrote an article for Scientific American, April 2002. They didn't want to use any of the pictures of any of our real systems as part of the two-page spread at the beginning because the resolution wasn't big enough and we had real running systems that didn't really quite work with zillions of people outside. So together with a little bit back and forth at the last minute, they came up with this illustration over here showing a bunch of people wearing AR eyewear walking around, and you're seeing sort of a lot of the overlays that they're supposedly seeing. The theme of the article was, what is your user interface going to look like in 10 years? And true to form, being an academic, I, of course, over-predicted. And 10 years later, we ramped into the future. And interestingly, April 2012, that's when suddenly everyone is talking about Google Glass. Not quite AR, but indeed a head-worn display with a see-through optic and, in fact, built-in computer and sensors and all kinds of other good stuff. So this is actually a slide that I used at ARE, back before it became AWE, ARE2012. And I actually made a comparison between what Sergey is wearing over here and a device from the last century, the micro-optical clip-on, noting that, of course, the device at the top is the computer, and the thing that looks at first glance very much like it at the bottom from the late 90s is actually just a display with a cable that goes off to computing and power and all kinds of other stuff like that. And at the time when I gave the talk in which I included these slides, the point I was trying to make is that this wasn't quite yet what we really wanted, and I was thinking more in terms of these things, which were basically unavailable to consumers. You could actually get a couple of these if you had the right amount of money and the right context. And you're looking at an older display from Minolta before they became Konica Minolta from around 2000. And, of course, the Loomis that you're seeing in the middle, and a Sony display being worn by Tom Hanks a couple of years before the talk down at the bottom. So all of these didn't really exist in any consumer kind of way. And we ramp ahead to 2014. And in this slide that I made up for a course that I just finished teaching a week ago, we can see a whole bunch of things, many of which you can see around the exhibition floor right now, all of which are real or about to be real, and you can put your money down and either you can get one right now or they'll be delivered sometime this year. And there's even more beyond what I'm showing you here. And in true C language-inspired terminology, I like to think of these as being see-through head-worn displays plus, in the sense that they're all integrating not just a display, but at least one or more of an orientation tracker, an input device or devices, RGB cameras, depth cameras, computers, full computers, in fact, radios, power, I forgot to mention over here. So clearly we really have advanced a lot, not only beyond 2002 and the 20th century, but as well even just 2 years ago at ARE. So the question is, given all that nice stuff, why didn't we have a lot of this earlier? Now, it's easy to say technology, we couldn't make displays that were that good, and yet some of the things that I showed you actually were not all that bad in terms of being displays, and they were around quite a long time ago. And so one thing I like to think of is the following thought experiment. Imagine that you had the sort of millennial eyewear that all of us would love to have, and some of us might actually be responsible for creating. And you had a time traveler who, coming from the year 2XXX, I'm not quite sure, but even that first X is going to be, I hope it's going to be a 0, goes back in time to 1999, and this person brings with them something that has the right appearance, the right level of comfort, the right kind of field of view, and personally I think that should actually match our full normal human binocular field of view, per pixel opacity, so at any given point in the very large number of retinal resolution points, you can determine how transparent it is, how much you see the real world, variable depth of field across the entire display, integrated sensors, and in fact, production plans to be able to actually make the darn thing in 1999 and make a profit on it, okay? So, in other words, that's everything I can think of. So what would happen? So if you actually had that display, besides the fact that many of the researchers here would actually buy the darn thing, well, what am I going to hook it up to? What computer am I going to hook it up to in 1999? And there were people who made wearable displays back then, and the answer was kind of grim. Nothing that has the kind of power, that has the kind of interface that we even count on having right now. What kind of networking were we going to have? I was very lucky in the backpack work that I did in 1996-97. I had colleagues who actually were working on doing IP over radio, and I was able to walk around with this experimental system and actually get out to the internet outside. But there was no Wi-Fi back then. There were no reasonable phone plans, at least in the US, that provided you with any amount of data, reasonable data, that is. There was no content. Right? I mean, the internet was relatively young, and let alone think of all the social media things that there are many companies that are counting on right now. There was no Facebook, there was no Twitter. It was basically that stuff didn't really exist back then. And so I would claim that if you actually had that time traveler go back in time, they would not be able to really make a deal and sell their technology to anyone who would actually be willing to produce it in any reasonable amount. Well, obviously, that's all changed right now. And part of the problem that we had then, and that has now been fixed, is that there is this missing milieu. There's this missing collection of other technologies that are absolutely vital to make something like this succeed. And happily right now, we've got computers, in fact, small enough to be able to actually fit in eyewear. Batteries, well, I guess they fit, but they're really not powerful enough. But that's just a matter of time. We've got the networking, we've got the content. Even if we don't have the networking here in the convention center, at least your phone probably has the networking. And so the point is that a lot of that stuff we need to succeed is actually genuinely really here. So another thought. There's this really neat thing that Google has, google.com/trends. And you can type in words and phrases, comma separated, and it'll actually show you relative amounts of searching. And so I'm showing you here the results from a day ago for AR versus VR. And the cool thing that's happening here is that in 2009, you're actually seeing things cross over. And of course, 2010 is the first ARE that later becomes this conference. I think it was 2009, Ori, was that when you started with Tish? 2010. Okay, it was when Arnie started? Yeah, I think it was either 2010 or 2009. But the point is that it's... And ISMAR goes back to 1998. Right. And that was 2008 at ISMAR, actually, right before that crossover over there. So you guys really were being prescient. So we get that crossover, and AR is riding in search above VR. And then an interesting little thing happens right around over here. You'll notice it starts ramping up a little bit for VR. And I suspect that given the amount of searching that's done on Google, that actually probably is statistically significant. And everyone over here knows what A is, right? That's a news item, right? $2 billion worth of news item. Now, so this is AR versus VR. Now, what happens if you add in Oculus? So we're the foothills in comparison with the big Everest, right, of Oculus, especially right around that announcement. But even before that, right, there's still, as we see, this incredible ramp up right around over here with lots of news articles, and people have actually started hearing about it. So this stuff is really real, and maybe, we hope, we will have our Oculus moment, hopefully sooner rather than later. So let's get back to the theme of making it real. And my claim is it's going to be real when it's anyone, anywhere, anytime, and maybe substitute every for any in this case. And so this is just, again, that little lower left-hand corner of that image from the Scientific American article. Everyone is wearing the eyewear over there. It was very important to me that it not be dark sunglasses, but you could actually see through it, and that it looked kind of, sort of like eyewear, even though a lot of these folks, I think this is all stock, photography, they kind of look vaguely zombie-like. Hopefully that will not be the case, okay? So what are the consequences of this kind of thing? What's it going to be like? What are the things that are going to be important? How are things going to change in our lives? So a couple of thoughts. One of them is, the idea is, and we already are doing this, okay? We're carrying with us information, technology. This little guy over here is one of my favorite characters from comics. He is Pigpen in Peanuts, and wherever he goes, he's a little dirty little guy. He throws up a little cloud of dust, and I think of that as being the information that essentially that he's bringing with him, information that he can have access to, information that you, looking at him as a third person, actually get to see about him. And of course, one way to do that would be with augmented reality. So if we're carrying all that stuff around with us, and it's literally everyone, not just the few people who might actually be wearing a wearable display right now, what happens? Well, we're talking about not just information, we're talking about displays, and I, as a researcher, use that term essentially to mean any kind of display, not just visual ones, things that you can hear, feel, see, smell, touch. Sensors that can sense all of those kinds of things. Computation power, okay? And of course, communication, meaning we can not only talk to other computational power sources, we can also talk to other people. And our devices can talk to other people's devices. So if we've got that kind of infrastructure with all those people interacting with each other and their devices interacting with each other and all the cross products of those ways of doing things, what do we get? So here's one suggestion. Right now, we often think about wearing a device that has some tracking technology in it, maybe even not just, say, an IMU, but also RGB cameras, depth cameras, all sorts of other kinds of things that sense the world with many different kinds of sensing technologies. Now, normally we think of all those sensors, they're great for me, they let me know more about my environment, but imagine if we have a bunch of people and they're all looking at, in the full sense and multimodal sense of what that means, each other and their own body parts. That may mean that I now know things about my body that you might not be able to see, things I might want to release to you. I'm making a hand gesture, for example. My camera is catching it. You can't actually see my hand directly, and your sensors can't either, and now I can let you have that information. Maybe my sensors are looking at you, and your sensors are looking at me, and I can see something about, let's say, your hands, because maybe you're not wearing your Myo or something, and your hands are outside of the range of your sensing cameras, but they're within the range of mine, and so now I can tell you, or my systems can tell your systems, about what it is that I see and sense. And the more people we have, the more different vantage points in which that seeing and sensing gets done, and the richer and richer model we have about ourselves and we have about everybody else. So in some sense, you can think of this as being kind of the new etiquette, in that if I'm having a conversation with you, I'm going to give you my sensor data, at least the relevant stuff, to make our conversation richer and more effective than if I simply kept it all to myself. And you, of course, will do the same thing back, because it's etiquette. We're all polite equally to each other. Another thought. How do you manage all this information? So there's that very old and very classical notion of window management. This is an image, a screenshot from a Xerox PARC Alto. The Alto dates back literally 40 years, just about exactly, to the early 1970s. So we've got 40 years worth of something that is instantly recognizable. Many of you probably have never seen a live screen running the stuff that ran back on the Alto, but you certainly recognize this as a bunch of overlapping windows, like pieces of paper on the desk, we used to say. But that's been 40 years that we've had this. In fact, arguably more if you go back to Doug Engelbart's work back in the 1960s. So if we have not just a display on our desktop or a set of, because they're getting increasingly cheaper, multiple displays on the desktop, but we have things that we wear on our heads, things that we wear on our wrists, as we probably all will as soon as a certain big company announces their iWatch or whatever they'll call it. If we have things that we carry around in our hands, wear on our waist, carry in our purse, et cetera, project onto the world around us, then we need to go, I think, from this model of thinking about window management to something that I'd like to refer to as environment management. This is, in fact, an image from a very old paper, 1999, that Andreas Butz and colleagues did with me, in which we had the notion of augmented reality being a kind of computational ether, all-encompassing. It's literally flowing all around us. It embeds other tracked displays. It embeds the environment itself. And it means that we can now overlay, visually or in any other kind of modality, information on that world. That means we can take stuff that is floating in front of us because it's being seen on our eyewear, and we can move it to another display, move it from that display to our eyewear, move it between two completely different displays, and maybe see it in the process of getting moved because we can actually see overlaid information on perhaps our hand that's moving it or whatever other way we have of getting it from one place to another. And so this raises, I think, a number of really neat research questions. So if we've got all this stuff, if we have everybody and everything which is integrated together, has the ability to display, has the ability to sense, and I'm wearing not just my eyewear, but I'm wearing my wrist-worn computer, I may be holding in my hand one or more displays of various sizes. There are ones on the wall, there are ones on the floors, there are ones literally floating in the environment around me. How do we control the information? How do we manage it? How do we coordinate all of this stuff, figuring out what goes where, how it's going to get presented based on the capabilities of the device? How do we even figure out where things are, for that matter? So that, I think, is one of the key issues that we're going to need to address as we get closer and closer and closer to an environment that over the next couple of years is going to become more and more like what we really are living with as we walk around wearing things of various sorts in environments that are just painted literally and filled with information. So one other question, where do you put stuff? Do you put it attached to your head? Do you put it attached to your body? Do you put it attached to a particular device? Do you put it attached to places in the world? Okay, these are all questions that we need to answer and then be able to go and control as we get towards a world that's like that. And so at this point, I'd like to just acknowledge students and colleagues that have working with me right now, funding agencies and companies that have given us funding. And to mention finally that if you enjoyed being here, I hope you'll also enjoy being at ISMAR in Munich, Germany in September.
Thank you. Thank you, Professor Feiner. We have time for perhaps one question, but we've got a special guest who's going to moderate a panel of for questions at the end, Nathan Linder from MIT Labs Fluid Interface Group. So while Sean White sets up, we can have one question to Professor Feiner, and then we will have plenty of time to really have a conversation at the end. I can't see anything else. Oh, yes. Good. Yes. Do we have a second mic? You can, because you're so near to the front, maybe just shout it out.
You gave a bold prediction in your early 2002 article about the future 10 years out.
Yes?
What's your main prediction for another 10 years?
Okay. Well, clearly, as I'm an academic, I'm a researcher, and when researchers make predictions, we make them usually based on best cases, like we're going to get all the funding we possibly will want, as will all of our colleagues, and people won't die, leave their companies, leave their universities, et cetera, et cetera. So I think that we are going to see this notion of lots and lots and lots of people really wearing stuff. We're probably going to see some additional sensors. I think that brain-computer interaction is something that I don't want to predict that in 10 years from now everyone's going to be doing it, but it seems to me that there's going to be a lot of success from what is right now relatively primitive early research. There may well be some things that might perhaps be on the market at that point that will range beyond some of the things that are commercially available right now. And in general, part of what I've learned from making predictions in the 90s about 2000 about right now is I'm probably going to be wrong and probably going to be overambitious. And therefore, right now, you're seeing, having learned from being burned, so to speak, a couple of times, I'm probably being a lot more cautious than I would have been in the past. So I think we're going to see the things that I predicted before finally actually happening, along with many of the predictions that many other folks here have made. Thank you.
Thank you. How are we going? Looks good. It's a great pleasure to welcome Sean White from Greylock Partners. He's also part of this long lineage that began at Columbia in AR, which really we all owe a huge debt to the work they've done. And if you get a chance after Sean's talk, Google some of the amazing projects he's done. It's like already futuristic stuff. So take it away, Sean.
All right. Sorry, this looks like it died for a second, but I think I've got it back up. All right. Nice to see everybody. So Steve gave me a perfect setup for my part of this particular section, right? So he was talking about how we carry information and technology with us. And so I'm going to talk about the role of wearables in augmented worlds. And just as an aside, a little bit about this. How many of you know who this is? Raise your hand. Yeah, a couple of you. So this is Hugo Gernsback, one of the earliest futurists. You probably know him as the publisher of amazing stories, right? 1926. Before sci-fi was actually sci-fi, Hugo was thinking about exactly what augmented worlds might look like, right? So we want to sort of follow in some of that tradition. And tell you a little bit about some of the things that we've been doing. I'm going to start off with a little context. I am currently at Greylock Partners, which is a venture capital firm. I'm an entrepreneur in residence there, doing a bunch of different projects. I also teach a class, CS377W, which is a class on wearable computing. And I'm going to probably go spend more time on some of the things we're doing in that class than on some of the entrepreneurial things, but feel free to ask me about that. And before that, as context, so I was in Steve's lab, that's where I did my dissertation, and then I ran a group at Nokia that was basically doing wearables and glasses and immersive types of things. And so I wanted to sort of frame it that way to give you a sense for where we go with this, right? So lots of things that you might wear, things that you deploy, stuff that you put on your body, stuff that's augmented reality, stuff that's just little buttons. So starting off, I really wanted to think about what we mean by augmented worlds, because it sort of helps frame where I wanted to go with some of the design principles, right? So there are a lot of ways to think about it. Ron Azuma, who's in the audience, always has a nice set of definitions that we often use. But I wanted to expand it out because AWE is starting to expand it out to really just talk about how it changes or extends our perception or our cognition, right? So that can mean a lot of different things. It could mean this, right? So this is an art piece called Open. You put a big piece of sod on your face. You have your ears completely covered. This is an augmented world, an augmented experience, right? And so is this. So this is a sensory room where you're supposed to go in and you have your senses addressed. This is more of a sort of pervasive computing kind of sensory world. But the kind of thing that I'm interested in has been the sort of marriage between wearables, different wearable devices, and how we augment the world. And so I like to actually get a little closer to the source, right? And so when you get closer to the source, you're talking about what the eyes see, what the senses see, where we're getting close to our hands, close to our tongues, the kind of stuff that Adrian Chiak does, right? And so often that means glasses or different wearables. And so for me, when we talk about the role of wearables, right, it's inherently that those are the devices that directly address our senses. Things that are projected are fantastic. When you go into a cave, that's wonderful. But wearables actually gets really close to the source. And then I think there are a couple interesting things about that. And so For the class, we often talked about wearables as devices that let us interact with and through the world and directly interact with it. And they're also a particular lens, right? So augmented reality is a lens in which we can talk about things and sort of talk about the future. I knew that Steve was actually going to do a great job talking about that as a particular lens. So what I wanted to then do with the rest of my 10 minutes was tell you a little bit about some of the things that we've discovered in the class. And oftentimes you'll see something like this and they'll say, okay, so this is a set of design principles, right? Or rules or heuristics. And I don't like rules. I don't believe in rules and heuristics and things like that as much as just, here's some things to think about. And in part, that's because there are always going to be reasons why you might break it. But hopefully, some of you out there are actually building either businesses or products or just ideas around augmented worlds and around wearables, right? So just again, to give me a sense, raise your hand if you're actually working on some of this stuff. Right. And so that means that your research or your business is dependent on it. And I can tell you that, and I'll put my Greylock hat on for a second here, when you see someone come in and they're making something just for AR's sake or just for wearable sake, it's actually not very interesting, right? It's worth saying, oh, maybe they've actually created something novel, but it's one of the first things that we think about. So I'll just go through these very quickly and tell you some of the things that as the students have gone through it. So first off, you really want to ask, why is it wearable, right? Why is it augmented? And it doesn't have to be, right? Like, there are a ton of things where people will say, look, I took this really neat thing, and I put it on, and now it's wearable, but it doesn't actually help you get to an interaction faster or help you do something that's either useful or pleasurable, right? So we've done work. Someone really wants to contact me. We've done work on, for instance, walking around and making music. It's not utilitarian per se, but in the context where you're walking around and you want your hands free, it actually makes a difference, right? So we always ask the students, why is it wearable? Why does it need to be augmented? The next thing that we often ask them to think about are microinteractions. So a colleague of mine, Dan Ashbrook, has done a lot of really interesting work on microinteractions. He did his dissertation work on it. And if you think about it, how many of you have now put on some of these test glasses, and now you've got a regular desktop from the regular world, and it's in front of you, and you now need to spend about 5 to 10 minutes doing something? You tried that out, right? It's a little frustrating. And it looks great in a sci-fi movie. It looks great when you do this stuff, and you're sort of doing all these things, and for 10 minutes you sort of change all this CSI great stuff. And the truth is that a lot of times what you're doing is you're actually sort of competing with something that's already out there, like your phone, right? And so there are these interesting studies that were done in Dan Ashbrook's dissertation where he looked at how long it actually takes for you to take out your phone and do something. And that's not even unlocking, it's just taking it out, and that's around 4 seconds. And so a lot of what we get the students to focus on then are the microinteractions. How long does it actually take you to do something? Now, I'm not saying that you shouldn't actually play a game that's 10 minutes in an augmented reality world, right? But you do want the interactions to actually be really fast when you're doing it. And you don't want to have to sort of go and pull stuff out or go and grab things. And again, that's where wearables becomes really interesting. It's because you actually have things that are close to your hands. And that brings me, actually I'm going to skip ahead one, to another thing that we have the students often think about, which is whether something is present at hand or ready to hand. This is kind of old school, right? This is from Heidegger originally, and then Terry Winograd, who sort of helped create, well, he did create the HCI program at Stanford, talks about this a lot in his books on design. And the point is, and some of you may say, oh, I've read Heidegger before, I understand all this, it's boring. But the point is that there are some things where you're focusing on the device, the hammer. As an example, you're focusing on the glasses, right? And there are some things where you're actually focusing on the task. So when you're focusing on the device, for an example, a hammer, that's when it's present at hand, right? And the problem is, in the end, what we care about is actually doing the things that we want to do. If we want to play Battleship on the ground, we want to play Battleship on the ground, not think about the glasses or the text thing that I'm typing in, right? If we are getting navigation, I want to think about where I'm going, not the arrows and the representations. And so that's when something becomes ready to hand, is when you think about the task, not the artifact, right? So the example of the hammer is that, you can look at that hammer, but really when you're really using a hammer, and the hammer is a nice example, you're just hammering a nail in, right? You're thinking about putting that nail in the right place, and hopefully, for those of you who have used a hammer more than once, you're not thinking about the hammer. Now again, these are just things to think about. There are times when you might actually want something to be present at hand because it's beautiful, right? The glasses that you put on are so beautiful, you actually want to keep them on and keep them present. But for the most part, if we're thinking about tasks, if we're thinking about things we enjoy and pleasure or games or whatever, you want to think about how to make all of that, all of the different wearable systems, the augmentations, ready to hand. And we extend that to interfaces as well, right? So let me go back to this one, dispositions. So dispositions is a sort of easy concept, and hopefully most of these, if you look at them, you say, that's obvious. Now, I just tick that off, and the next time I actually am building these immersive systems with wearables and things like that, I'll just have already thought about it. So dispositions is a combination of ideas. One of them is about the pose and relationship of the device to the user, right? But it's one of these things that often doesn't get thought about when we are making wearable devices, right? And the example is that you sometimes will have glasses, or you'll have some new wearable thing that you put on your arm, or that you put on your waist, or on your knee, or something like that. And we don't think about all the places it could go, or the places it goes when you're not using it, or the resources it uses cognitively or kinesthetically, right? And so when you're actually designing these devices, we have the students really think about where it's going to go. Where's it going to go when you're not using it, right? Because the whole point of all of this, mobile augmented reality, for instance, is that you actually aren't just sort of locked in a room. You are free to go about your way in the world, right? Now, sometimes you design this in on purpose, and sometimes you just kind of figure it out. You'll notice that a lot of people with Google Glass, some people with Google Glass, instead of putting it here, now start to wear it around their neck, right? It's an alternate disposition, and part of that is just because of the perception, right? Sometimes it's just easier not to have that in between you and someone that you're interacting with. But it hasn't necessarily been designed that way. And if you talk to at least the glass folk I have talked to, seem to agree with that. And there, of course, there are transition costs for all of these. I'm going to speed up just a little bit so that I stay roughly in time. But transition costs, so for instance, there are a bunch of rings. My group, we made a bunch of different little rings. I've seen a couple here, right? And if you're taking the ring from one hand to another, or you're moving it around, or you're taking it off because you're charging it, there are costs in the transitions of that. And so you want to be thinking about those as well. So there was a whole fashion panel. I don't really need to go into much detail on this, I hope, right? But when you're actually working on the immersive system and the wearables, we actually often ask the students to really think about what kind of self-expression that's going to be, what form of aesthetics the person who's using it cares about, and how that then takes form. So in the panel before, right, there were these people, a great group of people who were making glasses. And what was interesting, though, is that there were a lot of statements where someone would say, it shouldn't be this, it should be that, right? But as I look into the audience right now, I already see about 20 different pairs of glasses. Each one is meant to reflect who you are, right? The examples out here are meant to reflect who these people are. And if you go to a glasses store, you see thousands of them. It's exactly why Google would make a deal with Luxottica, right? It's that acknowledgement that any of the things we do, there's probably not one right solution, and that's generally true for wearables, right? Is that there are going to be multiple solutions, and we keep the students really thinking about that. Sometimes it's also a signifier, right? So there's this really interesting fact, or at least interesting to me. A lot of people will sort of say, well, are things like augmented realities, wearables ever going to hit mainstream? And so I ask them, well, are 8.5 million units sold a mainstream device? And they say, yeah, of course, that's a mainstream device. And so there are already 8.5 million wearable cameras out there in the form of a GoPro, right? They just filed their S1. You can verify those numbers. And so it's not like it's something that's going to happen. It's something that is happening. And you know, Steve had this nice graph on the curve about people's interest, especially after Oculus hit. Those are all kinds of interesting issues that we'll really have to think about and deal with. A personal one that I'm not going to talk about today, and I'm going to run out of time really soon, is around wearable video, in particular, all of the sort of interesting issues that come up as we're taking video, if that's for registration and tracking, if that is just for content sharing, all of those different pieces that get us kind of excited and upset, right? All of the sort of emotional things that those pull up. So the last one that we've often found with the students is that, and I find this in a lot of the AR work as well, is that people often will think about the artifact and not the system. And again, if what you care about is doing your next research piece, that makes complete sense, and that's great, and you are doing something novel, and that's fantastic. But a great idea is not always a great product, and a great product is not always a great business or a great system. And so when we have the students thinking about their wearable systems that they're building, we really try and have them think about the entire system, right? Not just one piece, but what is it going to connect to? How is it in their lifestyle? Is it going to be something that gets information from something else? And so they have to actually, even if they don't implement it, they have to start thinking about what are the sort of social aspects of it, the cloud aspects of it. And that's generally true. I mean, the Pebble I'm wearing right now is interesting because it connects, not interesting because of it as an artifact. So, what role do wearables play in an augmented world? Well, they are our augmentation, right? Until the point, of course, in which we have embeddables and neural interfaces and things like that. And we had someone come give a guest lecture about that. That's great. But for now, wearables really are the augmentation that we have, right? And so those different considerations, the things to think about, are what we often have the students think about as they're building it, and that makes better products. It makes better ideas for what they're doing, and you know, in some of the cases for the CS37 class, I think probably better businesses. So hopefully all of you are going out. I saw almost everybody's hand raised, making your own cool, amazing stories. Maybe you will be the next Hugo Gernsback, and not just envision it, but build it. He was an inventor as well. You saw those cool TV glasses, right? If you have any questions, my name is Sean White. I'm not the snowboarder, I'm the other guy. And you can reach me, swhite@greylock.com, or just Sean White at Twitter. Thank you.
So we do have time for one question while Gaia Dempsey sets up her laptop. So if you've got a question, wave your hand, because I can't see a thing in the lights of my eyes. And there's also we're going to have a short panel conversation. So if you don't have a question now, you'll have a chance to think about it. Oh.
Hello. What is the commercialization of what you're doing? At this point, are you looking at ideas that you can see a roadmap to what the ROI, or is this strict envisioning for a while?
No. So I think we're all seeing there are companies that are both wearable and augmented and VR that are getting funding now. We've even seen an exit for at least one, hopefully a couple more. To me, the thing that's interesting is that some of those are actually taking technologies we knew about and just doing a good job at actually making them consumer friendly, right? The thing that's true, by the way, like Google Glass, awesome, but really, it's at least in its current state, it's an enterprise product, and so the people who are sort of focusing on that, because they don't have to worry about one of those considerations I was talking about, right? They don't have to care about how somebody looks when they do it. Yeah, that's right. Right, great, thank you.
Thank you, Sean. It's a great pleasure to welcome Gaia Dempsey from DAQRI. Hands up here who's been to the DAQRI booth yet. Okay, not everyone. It's a must, absolute must. I myself, in previous years, occasionally missed some of the expo from doing this, and it's really essential. There's amazing stuff there. DAQRI is really, I think, an important company in the AR space because they've really, while they've, as you saw, perhaps if you heard Brian Mullen's talk, done some amazing industrial AR. They always focus on things from a design point of view first, and I think that's been a real sort of secret to their success. And I'm going to hand over to Gaia because she will, I think, speak to some of that. Thank you.
Thank you, Tish. That's okay. Yeah. Hi, everybody. Augmented reality represents many things to many people. It has a unique power to inflame the imagination of technologists and storytellers alike and conjure up ideas of a limitless science fiction future. But have you ever stopped to ask yourself why? Augmented reality has made its way into the lives of everyone in this room for different reasons. Think back to the first time that you experienced augmented reality. Let's see a show of hands. Were you excited by the idea that augmented reality was the first thing you'd seen that could reasonably be expected to give you superpowers? Okay, a few people. Maybe you saw it for the first time and you said, this kind of AR interactivity is the future of content delivery. This is how I'm going to be delivered content in all kinds of ways for all types of reasons in the future. Okay. Or maybe you saw a storytelling medium that can change your environment while still maintaining a connection to that environment, and you saw a limitless creative canvas. Was that maybe something that resonated with people? Great. So I think at the core of all of these things, there's something deep inside of us. For millennia, we've had myths and legends about wizards, technicians, deities, and magical beings who could change their surroundings with a wave of their hand, with a thought, a wish, or a command. There are very few motifs in human history that have the kind of staying power that can compete with this kind of mystical power that has appeared in our stories over and over again. From Zeus and his lightning bolts to Game of Thrones today, mystical powers are a long-standing tradition. When the world becomes truly integrated with augmented reality, we all will be able to change both digital and physical aspects of our reality in much the same way as the heroes in our stories. Mark Billinghurst touched upon this yesterday when he spoke on his research about multimodal interfaces that incorporate both speech and gestures. So when things like those interfaces and other types of augmented reality interfaces are truly incorporated in our everyday lives, what does that mean? That means that in the future, we'll be able to control our applications and aspects of our surroundings as easily as today we select an option with a click of a mouse on a web page, or build something in Minecraft, or give a voice command to Siri. The implications from a cultural standpoint are profound. Augmented reality UIs will act as the control systems for objects, tasks, work, and play in our everyday lives. And in order to make this vision a reality, people like Mark Billinghurst and Stephen Feiner, who spoke before me, need to continue to do the research that they're doing. And companies like DAQRI need to continue to experiment in the marketplace with ideas and apps where we get direct customer feedback from mainstream consumers. One of the lessons that we've learned along the way is that we need to do user experience design really, really well in order for this to work. We want to create content that is consistent with what we expect in terms of physics and UI functionality, while simultaneously pushing the boundaries forward of what it is possible to expect. So let's talk about some specific examples. Enchantium is a product line created by DAQRI that lets toy makers and game designers add a new dimension of play to any game or toy. So I wanted to talk briefly about musical strings, which is one of the games in the Enchantium app. It creates a surprising and delightful user experience while at the same time conforming to some of our expectations about how physics work. So in this application, you put down these target images and they find each other through the app. They send over a beam of recognition and create strings that allow the user to make music. And when you pull them further apart or put them closer together, the pitch and tone of the sound changes. So you're actually teaching kids about the physics of strings with this toy and letting them make music and have fun along the way. Another example is Elements 4D, which if you visited the DAQRI booth, you may have seen already. This was a passion project that we put on Kickstarter, the Kickstarter platform, about a year ago. And it generated a lot of interest and engagement in the education community. We sort of expected it to be a thought experiment that would engage the augmented reality community more than anybody else. And at the end of the day, we were really surprised to find that it was teachers themselves, particularly in the K through 12 classrooms, that really gravitated toward this app and started using it in their lesson plans. One of the things that's really unique about Elements 4D is that it has this really tangible aspect. The blocks themselves, even for young kids, have a great tangible quality that you can move them around and look at them and learn about them and look at this beautiful design. And then they transform. When you look at them through the app, they transform and they become a 4D representation of that element. And when you put two blocks together physically in the tangible world, that creates a reaction and it forms a new compound in 4D. Anatomy 4D is another application that we designed. These are the target images, and this is one of them in action. So this is nearing 1 million downloads worldwide. We're really excited about this application because it's being used, again, in classrooms around the world, in university settings, and by students in medical school, nursing school, and sports medicine programs to study the human body at home. So these types of experiences are enabled by a platform that we created called DAQRI 4D Studio. 4D Studio is such an exciting tool because it allows people all over the world with different levels of creative and technical skills to create 4D experiences. I'm very excited to see what people will create, and I hope that we'll see things that surprise us. And I also hope that at DAQRI we can continue to explore and push the boundaries of what's possible. Because to me, augmented reality is a tool that lets people overcome our hardware limitations. I'll explain what I mean by that. Well, one of the main hardware limitations of the human body is that it ages and eventually dies. But I don't mean to say that augmented reality will let us live forever. I'm talking about a different hardware limitation: the human brain's inherent inability to make good predictions. Augmented reality can be used to pre-visualize the effects of a course of action before that action is taken. It lets you preview the future and therefore make better decisions in the present. Imagine that you're playing blackjack, and as each card appears, you can see the probability of getting a good score appear in front of you for yourself and for your competitors before deciding how to play your cards. This is the distillation of the essential principle that I'm talking about. I want to have some fun with a Hollywood example of what this means, because really some people can already do this. I might have to narrate this if the sound doesn't work. Oh, let me see. Well, the scene might be familiar to some people. Let's see. How many people here have seen the Sherlock Holmes films? Okay, like a lot of you. So he has this ability in the films to pre-visualize the actions that he takes. And in this case, he's having a boxing match, and he's able to pre-visualize 10 or 12 steps down the road before deciding what to do and what actions to take in his boxing match. But if done correctly, augmented reality will allow people, even people who are not Sherlock Holmes, to visualize the future. So perhaps a more useful example than a boxing match, or something that some of you may be able to relate to, would be when you're running an experiment and being able to pre-visualize the probabilities of outcomes before taking the next step. Our industrial 4D offerings are a great example of this principle in action on the factory floor today. And I invite you to visit the DAQRI booth to see this in action. In many other fields, like science, medicine, finance, and the weather, we do already have the ability to model quantitative outcomes and probabilities. The fields of big data and predictive analytics have come a long way. And this is especially useful in a business context. Tom Davenport says that decision-making and the techniques and automation to support it will be the next battleground for organizations. And I believe that this is an unmatched opportunity to create value in the augmented reality landscape. Why is that? Well, because today the tools that people use to do predictive analytics look like this. The UI, in order for this to be useful in our everyday lives, the UI needs to be much more accessible, much more understandable and immediate. For Sherlock Holmes, the spreadsheet wouldn't have helped. To be valuable, it needs to be in real time, in context, when and where it matters. Here are some examples from the Harvard Business Review where predictive visualization is being used today and where I think it could be used in augmented reality. So some of these include supply chain, pricing, human capital, financial performance, and research and development. Speaking more broadly, environmental outcomes, financial outcomes, and medical outcomes could all be presented in this way. 4D Studio enables a new generation of app designers and an entirely new app ecosystem. The data is out there, and the tool is finally here. We can't wait to see what you'll create. Thank you.
Thank you, Gaia. If you'd like to take a seat and Stephen and Sean and Nathan want to come to the stage, we have a chance for a little moderated session. And if you would like to wave your hand if you have a question, because I know Nathan's got a few questions lined up, but if I'd like to see just so I don't leave anyone out. Okay, Nathan's been putting together questions, so they'll just have a little moderated session, and if you have a question that comes up, wave your hand and we'll try and get you in. Thank you.
Hello, can you guys hear me? Great. So, thanks everyone. This was wonderful and great to be here again. Wonderful to see this venue grows every year. And so I listened to all of you, and I kind of want to, between, provocate and potentially, get you guys thinking together on some few interesting things. So I guess I want to start with you, Steve. So if you go back to the origins of AR, so we all know the famous work at Boeing, and we all know it kind of started from industrial AR, and you're kind of Mr. Industrial AR. And so I want to quote research, and you're also a researcher, and we have a lot of people thinking about starting businesses, but also a lot of researchers. So I think that transition is very interesting. So one question, and this is, I'm quoting research from, how should I pronounce his name? Help me out. The UNC, Pierre.
Pierre Fitzgerald.
Yeah, I didn't want to make that mistake. So Pierre, his work is wonderful, wrote a paper called Is There Reality in Industrial Augmented Reality? Have you seen this paper?
I have not seen the paper.
So in this paper, if you jump to the conclusion, it shows very systematically how out of numerous years doing research, there's only 2 deployments that moved from lab to the real world.
Okay, I'm not sure that's necessarily true, given that there are many folks in the industry who don't necessarily want to talk about things that they're actually doing.
So you think, but in a way, I guess I don't know how you count the years that AR existed, that since 1968. It's fair. I mean, some people start earlier. It hasn't become mainstream in industry yet.
I'd say it's definitely true.
So why is that?
Why? Okay. I think there's lots of reasons why. Technology, availability. If you don't have people who are actually doing research in industry, as for example. Okay, so now you can hear me. So why is AR not mainstream in industry? I'm probably not the best person to answer this. I'm sure there are plenty of people from industry here who can help tell you why it's not mainstream in industry. There certainly have been attempts to experiment. I can think of the wonderful work that Dave Mizell and Tom Codell and colleagues did at Boeing back in the early 90s, which did not result in an actual deployment at the time, in part because, as they tell it, Boeing just did not want to actually follow through with it. But there are, I think, a number of people here who are showing some very promising things that have all of the effort, or at least some of the effort, already put into them to make things that would be the kind of bulletproof that you might want them to be in something that gets deployed to people who are not actually the developers. And so I think there's a difference between, for example, what Tom and Dave were doing, where they were really developing the stuff for a company that could afford to have that kind of forward-looking research, versus companies that don't have folks who are developing stuff. And if they're going to buy something, they need to buy a solution that will really genuinely work without the constant intervention of other folks. But again, that's my outsider, not being an actual person in industry's viewpoint of why. Needless to say, with lots of things having to do with the particular technologies and their robustness and lots of that, what I called milieu before, of making sure there was all the other stuff that was needed to actually make things real.
Great. So this is a great segue for you, Sean. Yep. So it's kind of like
I may or may not need this. I don't know.
Yeah. So a lot of people talk about, okay, so what is the killer app for AR? And I get between very confused and annoyed by this question, because I think it's the totally wrong question. I think the real question is what would AR is absolutely essential for? So what kind of things, and this might answer also a part of your, kind of extend your answer, like why we don't know why it's not mainstream yet. So what do you think is absolutely essential? What can we only do with AR that we can't do with other things?
That's a great question. I haven't heard it framed in that way before. So at a high level, I'd say distributed perception and cognition, and by that I mean the overlay of things that are not real that we can then see, right? Sorry, not physical that we can then see. The Milgram thing always bothered me, that it was real versus virtual. I always wanted it to be physical versus virtual because it's all real. And so when you actually need to overlay something and have it registered, there's no other way to do that except augmented reality, right? Now, you can do that in a projection. You can do that wearing glasses. You can do that wearing handheld devices. But, there even tangible systems, for instance, or there are, if you sort of ticked out the different ways in which you could try and do something, right? My sense is that sort of fast, immediate overlay of live information, live objects, live registered stuff is something you just can't do with anything else besides AR.
Great, and this is actually the best segue for you, because you guys at DAQRI are actively involved in building a real business around this. So can you talk about what business models you think will emerge? For example, one thing I thought about are we going to have like a hire a clone service with your technology? Are we going to have a zip human, for example, with all this wearable and the stuff you guys are working on? What do you think?
Well, I think that the question that you just asked really relates to what the business case is. So thinking about what can you not do any other way? Where is augmented reality truly essential, and where does it provide value and or cost savings or performance features that you can't get any other way? And that's really what we look at DAQRI. It brings to mind an anecdote from one of our customers at Raytheon, who has told us this story about being in the boardroom with, over the last, he's been in the industrial space for the last 2 decades, and really having high-level conversations about the quality of, the errors that were being made, human errors in industrial manufacturing settings where there's really zero tolerance for error, particularly in industries where there's a high mix, low volume output like aerospace, where you really are creating a single piece of machinery or equipment that's very complicated, very costly, and you don't have the opportunity, if you're sending it out into space, or perhaps like an aircraft carrier, you're sending it out to sea, you don't really have the opportunity to fix it if something goes wrong immediately. So you really need to make sure that everything is exactly as it needs to be before it goes out. And these conversations, for the last really 3 decades, have struggled and grappled with the problems of errors and continuously finding that their systems are imperfect. And augmented reality has kind of dropped in and become a solution that provides the real-time quality assurance through computer vision and some of the on-site, in-context training capabilities and operational data that is in real time, in context, that is absolutely invaluable and can't really be achieved any other way.
Great. So we're quickly running out of time, so I want to ask one more quick tension question to you guys. And here's the tension. And this, I think, goes very nicely with what we're seeing in this year's conference. So I think it's fair to say the theme of this year, what's very clear, is that we have eyewear, and it's happening. And so what I'm not clear is are we augmenting people, or are we augmenting the world? And I think this tension is just, kind of like the elephant in the room.
I think that we make the world, right? In our own minds, every time that we look around, or every time that we tell a story, or every time that we tell our own story internally, we are world makers.
Yeah, but just to crystallize, and I'll let you guys do it.
Yeah, I know what you're saying.
It's not attention.
No,
okay,
it's 2 sides of the same coin, right?
Okay.
So pervasive computing, UbiComp, and wearable computing, augmented reality. I think these are all trying to answer the same questions, right? It's just, are you instrumenting a space? Are you instrumenting a
But
person?
this is not theoretical. This is very specific. We're talking about us wearing, like, I don't wear glasses, for example. Not Google glasses, just in general. Maybe too young, but I don't. But I have to wear this prosthesis. So that's augmenting me.
Yep.
So you said there's no tension. Can you?
No tension. I think it's more of a harmony. It's more of a harmony than a tension, and that's that by wearing something or by holding something that lets you see, hear, otherwise experience things you wouldn't be able to experience, you are both enhancing what you're capable of doing, and of course, at the same time, you're also providing that information, putting it out in the world so you perceive the world as having that stuff in it. And if it really were the case that you had to have one or the other, if that made any sense at all, then it would be a tension. But I think it's really, they're completely complementary ways of looking at things.
Okay, great. I think that's all the time we have.
Thank you, everybody. Yes, it's lunch, so I was just realizing the boxes would vanish if we didn't end.
Okay, go quickly.
Thank you.
All right, thanks.